Get started. Thank you for all attending my talk here on CAT integrative perspective. This will be a little different than a lot of the other talks here. So most of the talks that we have here assume one and two situations. Either they're fundamental research on CAT methodology or multi-state testing or something like that, in which case they're talking about new algorithms, new formulas, all that kind of thing, which I think is great, of course. Or it's about a large organization that's already doing adaptive testing, and in some cases it's both. You got a large organization doing lots of testing, and they're inventing cool new stuff to do it. My work is more what to do about the other 99% out there. So there's lots of assessment out there that's not yet CAT. Or is CAT but not doing it very well, or there's other, not even CAT, but there's other different ways you can improve, use some advanced methodologies, and how do we get there? So the way I think of it is like if we were in the bicycle making industry, a lot of what you see here at this conference is about making the Tour de France bikes 2% faster. And I'm more interested in, okay, how do we make a cheap, reliable, self-assembled bike that we can get to more people in Africa so more people are on bikes? It's a completely different engineering problem, but it's still quite interesting. So I'm going to talk about some of the different pieces that surround CAT. That is, how would you go about developing a new CAT program or even investigating whether a CAT program makes sense for you. There's plenty of resources out there on the technical aspects of CAT. You can go get books on CAT describing what the different pieces are. You can download Concerto. We just saw Concerto earlier. For those of you who were over there, free online open source adaptive testing platform. And even if you completely mastered how to use that and were an expert in R, how would you go about establishing a CAT program? And by program, I mean an assessment program where you're managing an item bank, you're delivering new forms or pools every year, you're working with stakeholders to make sure that the scores you're getting for people are meaningful. It's these bigger questions that you're dealing with that are actually still relevant to the engineering of a CAT. So there's pieces that go into it like project management, of course. That is, you've got to determine what are the things that need to be done to develop a valid CAT, what kind of documentation you need in place, what people you need on the team, all that sort of thing. You got to worry about the financials. First of all, whether a CAT is financially a good idea for the program that you're trying to work with. And later is how much is it going to cost? What kind of funding do we need? Questions like that. Third is content development. That is, once we've determined what our needs are for the test in terms of developing content, how do we actually go about and develop that content and make sure that it meets our quality constraints? And in many cases, you got to worry about sales, marketing, and branding. And I use that term pretty broadly here because even if you're not in a commercial setting, you're still selling to people. So if you're doing K-12, you're selling your assessments to teachers, convincing them that it's providing appropriate feedback to the students that's going to help their instruction. It's a sales job. And you got to keep that in mind. And part of this, of course, is then producing a product that is easily sellable. And so we're not just talking about being psychometrically valid here, it's about meeting the needs of your stakeholders. So you got to keep the wider perspective like that in mind. And then also development and integrations. That's another big aspect here because there's a lot, even if you produce the perfect CAT, you've got to be able to get it out to the people that need to get it. And there's different situations and they can be quite different. If you're in universities, you might have online courses managed in Moodle or Blackboard, but they want to have it linked to a CAT, in which case you've got to connect yourself to Blackboard or Moodle. In employment testing, the big thing is applicant tracking systems. So like if you were to go to apply to work at Target or Best Buy or McDonald's, you fill out a form online, you get you're created then as an object in an applicant tracking system. And if you meet the basic education requirements, they send you to take a test. In a testing platform, the testing platform sends the scores back to the applicant tracking platform. And then if you have high enough scores, you move on to the interview, let's say. You can see how here this is not just about the CAT, it's about making sure that you've got all the pieces you need to make a successful assessment program. So I'll talk a little bit about some of these pieces here, but you can see a lot of this can be pretty specific to whatever it is your assessment situation is. So I'm going to try to be broadly talking about these different aspects, but At some point, it's going to just be sit down, determine what your stakeholders are, determine what types of integrations you have to worry about, whatever it is that you would consider the requirements to make your program a success. So one of the pieces, like I mentioned here, is that there's no shortage of research on the technical aspects of CAT, like IRT. If you want to go learn about item selection algorithms or how IRT scores people or what the A, B, and C parameters are, there's plenty of resources out there on that sort of thing, but there isn't resources on how to actually develop an adaptive testing program. That's where I'm going to try to get to. The first step here is to develop a plan. You got to define what your goal is, what you think your goal is at this point, because that might change, but at least get some idea what your goal is. Then decide how you would get there. Work backwards. Okay, we want to have an adaptive testing platform that delivers these 5 tests in schools across the country that's delivered, let's say, at the beginning of every school year. And we want to make sure that the scores go back to the teachers to help the students prepare for the school year, or whatever it is. Okay, what do we need to get there? Work backwards. We're going to need item banks. We're going to need a CAT platform. We're going to need it connected to the student tracking system. Whatever it is, pieces that you're going to be involved with, decide what those are. And then you got to estimate the feasibility and cost here too. There's feasibility and cost issues both from the psychometric perspective and from the non-psychometric perspective too. And I'll talk a little bit about both. So from the psychometric perspective and bleeding a little into the non-psychometric stuff, I've got a 5-step model that I like to talk about as the framework for how to develop an adaptive testing program. And it's not a complete recipe, but it's pretty close in that it covers all of the major pieces that you'll need. And it's going to help you identify the choices that are best for your organization in terms of meeting the needs of your adaptive testing program, and then to decide or investigate which of those pieces are probably the best for you. It's going to then also lead to quality management and project management. By following this process, you're going to make sure that you've dotted your I's and crossed your T's and made sure that you've documented the reasons why you chose each of the aspects along the way. And that, of course, is pretty important because if your test were ever to be challenged, you can just point to this report and say, okay, here's why we chose this SEM termination criterion with a minimum of 30 items and a maximum of 60 items, or whatever it is. You can say, we did all these simulation studies, we looked at our contact experts, we looked at our item bank, and we've got this 30-page report detailing why we did this. So if somebody were to challenge you, you could just hand over that report. So here's the 5-step model, and most of my presentation today is going to go into each of these in a little more detail. First step is feasibility, applicability, and planning studies. That is, you want to first determine if what you want to do is feasible, and then second, what is it going to take to get there, and what's it going to cost. The key pieces here, the primary work, are a Monte Carlo simulation, and if you've used the program SimulCAT, who the author is here, highly recommend it. It allows you to easily simulate many different CATs on many different situations, like what sorts of termination criterion work best for you, what sorts of item selection work best for you, whether you need exposure controls to enhance security, how big does your item bank need to be. Pretty important questions that you would be asking if you're starting out a CAT program. You can easily investigate in SimulCAT, and it's free. You can just download it and play around. But then the important thing here is that you take the results of these simulations and make a business case evaluation out of it. That is, if you know, okay, all these simulations say that CAT's going to reduce my test length by 47%, but I'm going to need to write these many more items for my item bank, and I'm going to need to have a CAT platform that costs this much, and I'm going to need to have an item banking platform that costs this much, and I need to work with a bunch of teachers to develop new items, and all these other pieces that go into developing a CAT. You can estimate the cost, but then you can also estimate the benefits. The biggest benefit usually is the whole reduction in test length of CAT of 50 to 90%. If you can estimate what the cost of seat time is for you, you can get a really big quality estimate of the savings it is for your organization. The classic example for this is in the certification or licensure testing space, where you're sending people to a testing center to take tests, and you're paying $25 or $30 or $40 US, whatever it is, to go sit in these testing centers per hour. So you've got a very specific knowledge of how much it costs to take the test. So if you're saving 2 hours of testing, you know it's going to save you $50 a student, whatever it ends up being. So this kind of information is essential for your business case. So once you've done these simulations, you're going to go ahead and develop an item bank that meet the needs that you've kind of figured out in the first step. And big piece here is item rank review. Not so much psychometric rework, but still pretty important. Then you want to pre-test and calibrate your item bank. This can or cannot be a big hurdle. If you've got a captive audience that is pretty large, piloting is not that big of a deal. I've got some clients that do 50,000 people coming through to take a test a year, and they're required to take the test, and they have no problem throwing in an extra 30 items. Yet you can build your item banks. On the other hand, if you're only doing 1,000 people or 2,000 people a year, it's a much different problem. And then fourth step, you're determining the final specifications for the CAT. That is, once you've got your item bank built, you're going to run some simulations on your actual item bank to define what the correct CAT algorithms are. And that's going to use a different type of simulations. It's called post hoc or hybrid. And then lastly, you're going to publish your live CAT, which involves putting it out on your platform and make sure all your connections working well, that sort of thing. So a little more on each of these, and I think I probably went into a little too much detail on number one already, because I was going to come back to it anyways. So the big question is CAT worth the investment? So we all know that CAT involves extra costs because you're going to have more software, you're going to need to hire a psychometrician or get a consulting one, or take more of your time if you're the one actually doing it. And you're going to probably need to develop more items. You're going to need to get a testing platform. Even if you're using Concerto that's open source, you're going to have hosting costs and the setup costs and everything else. Because open source doesn't necessarily equate to free, but it's still quite powerful. And the goal of this first phase here is that you want to determine what you think your project timeline is and what you need to do to get there. So the first answer, like I mentioned before, is evaluating the psychometric feasibility before you get into the non-psychometric stuff. That is, you run these simulations here using a software like SimulCAT, and you create an experiment, and it really is just like your old experiment that you learned in your Intro to Statistics and Research Design course, where you've got your independent variables you care about, and you've got your dependent variables you care about. You set up a study, you run simulations in each of these. You can't do hypothesis testing because you control the sample size, but you can still set it up like an experiment and in ways to answer the type of questions that you want to answer. Is item bank size important to you? Well, generate 3 different item banks and see how it affects the quality of your test. Is test security important to you and you're worried about item exposure? Well, SimulCAT has 5 different item exposure algorithms. Let's see how each of them work. It's pretty straightforward from that respect. For those newer to adaptive testing, and I know some of you are like, this is your first exposures coming to this conference, there's 3 types of simulation studies. Monte Carlo simulations use completely made up data. That is, we've got no real people yet. You might have real items, but oftentimes you don't even have real items. You're just simulating, okay, what happens if I do a CAT with 300 item banks on 10,000 people, or 200 items in my bank and 10,000 people? How is it going to turn out? Post hoc simulations, also called real data simulations, are where you're simulating what CATs are like on real data, usually from a linear test. So if you've got a linear test that's 200 items that you're already delivering, you can easily plug that into software and simulate what it would look like with a CAT. And it'll say, okay, you're going to get similar level of accuracy using only 103.2 items on average instead of 200. It'll give you answers pretty clearly like that. So those are pretty useful. And then lastly, there's hybrid simulations, which is a combination of the previous 2. That is, suppose you've got real data, and because you've been piloting your item bank, but every person has only seen 50 out of the 200 items. So you've got 150 empty spots in them. So you're going to fill in those 150 empty spots with fake data, but use real data for those 50 items you do have. So at this point in your stage, you're doing this feasibility, you don't have any real data yet, so you're going to do Monte Carlo simulations, most likely. So you're going to generate some plausible situations based on what you know about your assessment program, in terms of item bank, item parameters, desired precision, whether you need exposure controls. All those sort of pieces are based off what you know about your assessment program. And then you're going to compare those results to each other, and often usually to fixed forms or whatever your current assessment approach is. I suppose it could be loft also. And you're often going to base those values on reality. So what you want to do here is think of the results table that you want to see. I said it's like setting up an experiment. So in this case, I picked 2 independent variables and 2 dependent variables. And that's my experiment. Pretty simple. There's only 2 levels of each of the independent variables, so that's a 4 by 4. So we've got 2 size of item banks, 200 items and 300 items. And we've got 2 levels of a target SEM for our termination criterion, 0.3 and 0.4. So this is just a quick study to see, okay, and then we're going to compare these, like I said, to the current test. So let's say the current test has 100 items, it's a fixed form test, and the average SEM for the examinees in this test is 0.32. You know that because you've given this linear test to actual students. And you want to see if we do a CAT on different types of item banks, is it going to produce shorter tests but still improve SEM, or at least leave SEM the same? So what you'll do is you'll run simulations and be able to fill in the table like this. And I got a pointer here, I believe. So what this is saying is that in CAT under these specs had an average test length of 47 and an SEM of 0.3. So it was a little more accurate than the linear test, but about a 50% reduction in test length. And then 200, also item bank, we had a higher SEM, which means your test is going to be shorter. But then, of course, the higher SEM means that it's less accurate than here. So the key is, this is all just made up data here, but you're going to set up something like this for yourself. And then lastly, as part of this, you want to make that business case evaluation. The simulations are going to let you answer the psychometric questions, but you want to be thoughtful in some of the rest of the aspects, which as psychometricians, we're not always exposed to some of these other aspects, so you might have to get other people involved from your organization. But what you want to do is make here a business plan for your CAT as a new product. Some of the benefits to the organization, of course, it could lead to increased sales and revenue. It can reduce the seat time, like I mentioned, for certifications. It can reduce time away. What I mean by that is if you're involved with corporate training, you're taking people out of actually working to go take this test. You're still paying them to be on the clock, so there's an actual cost of time away. And in K-12, you're taking teachers and students away from instruction time to make them take this test. There's a time away cost. And there's security issues too. You're probably going to improve security with CAT. Some of the costs are sales, of course. If you're going to be selling this as a product, you're going to have sales costs. You're most likely going to have support costs, especially if you're going to have more moving pieces. You're probably going to have costs with development, either internally or externally, if you're going to rent somebody else's platform. And there's going to be also probably increased costs with tech from more like a hardware and DevOps perspective. So what you're thinking of here, in many cases, it's like launching a new ed tech company. And I've got the Silicon Valley logo up there. That's one of my favorite shows because I live that every day. And you want to survey the users to think, are they going to think that this new CAT product is meeting their needs? Is it going to improve assessment? Is it going to increase student engagement? Is it going to provide more accurate scores? Is it going to increase test security? What are the needs for your end stakeholders, and is CAT going to do those? Is it going to increase revenue for your organization? Or in some other way provide a positive impact, like in K-12 you're reducing time away from instruction. So there's lots of aspects like this to consider. Second step is developing an item bank. Now that we have this idea of what we need in terms of the simulations, how big of an item bank we need, we've got to go ahead and develop it. There's CAT-based considerations that are involved with this, but of course there's your normal test development considerations like blueprints and cognitive level, whatever it is that you have as your guidelines to develop items. Next step is to go ahead and pre-test the items. That is, you've got your item bank. You need real data on it to calibrate it with IRT, as you know. And you got to go out and figure out how to pilot that. In some cases, it's going to be giving it to a large sample of people. Like if you're, I went to one on patient-reported outcomes yesterday. They were these were surveys delivered in like clinics and hospitals across the U.S. There's companies out there that help you find people to take these tests as a calibration sample. They'll pay somebody $5 to take a test. So all they did was go out and hire this company to get 50,000 people to come in and take the test. And they said they had most of their data in 72 hours. It was pretty nice. Most of us don't have that luxury, though. The third step, then you're going to calibrate, usually with IRT, and you're going to perform all your normal due diligence for your item quality. That is, you're going to evaluate dimensionality, do distractor analysis on multiple choice questions. If you're doing drag and drop or other advanced item types, you're going to really make sure those are working. This is nothing new here based on what you're already doing. Then the fourth step is determining final specifications. That is, now that we've got our real item bank and we know what all the item parameters actually are, let's run some simulations on those to make sure that things are still going to perform like we want them to perform, and that we can document that they are going to perform like we want them to perform. So you run the simulations using the same things that you found in step one, and check to see that the results still come out looking the same. This is the key piece for validity, documentation, and defensibility. You want to make sure that you've got all this stuff documented, why you made these choices. And you can also talk about things at this point here like timing limits, which you don't know until you have how many items you're going to use. Last step is to publish a live CAT. You go ahead and put it out on the testing platform. You need a CAT engine. In some cases, it's easy to get one. You know, if you're using Concerto and it's a small scale deployment, that's less of an issue. If you're doing like a nationwide thing where you're doing 50,000 tests concurrently throughout the day, it's a whole different level of scalability. And the last step here is maintaining the CAT. Like fixed form testing, you're still going to want to maintain your testing program. Pilot new items, rotate out the bad ones or ones that are getting overexposed. Check to make sure that things are working on, you know, just like you would take your car in for checkups or, you know, go into a physician for checkups. So back to the big picture here, that 5-step model focuses on the test itself. There's all these other things to worry about too. I can't tell you what it is to consider for your organization, but it's also important to remember that you're going to have to take your findings from this, go compare these to the costs and benefits for the rest of your organization in terms of how you're going to roll out these things. And I've got some examples here, like K-12 government, employment testing, credentialing, but I'm out of time. So if you have any questions about those, I'll be happy to answer them after the session. Okay? Any questions to start with? Yeah?
Question. And you know, schools use apps, Google Classroom. Yes. Maybe a CAT integrated into Google Classroom. What do you mean?
It could be integrated in that, like you could have an API link from Google Classroom to a testing platform like Concerto. And then once the test is done, it sends a score back to Google Classroom. That thing is done in many situations, not just in classes. Like I said, it's also used in employment testing.
But Google may be interested to use CAT tests.
I think they should.
And it's good when it's for CAT or Bradford.
Yeah. I don't know, but
And how many years it will be to this process? I suppose it's will be because it's a big corporation and they're interested in education, so a lot of software and apps for all countries, and for me it's cheap and it's the first step to use. I think it may be, but in how many years for it process? Maybe what do you think?
I think for a project of that scale, it's certainly a couple of years. It'd be enough of a problem to try to find the right person in Google to talk to. And I think it also depends upon the application. Like if you came with a big situation like, you know, testing people across Russia, they would be interested because they're like, oh, 100 million more users. They would be much more receptive than smaller scale situations.
And the second question, if maybe software or websites, what in your model, what is it better? Software or website? Can we sell only a website, no, without software? All algorithms or procedures of CAT realized only in the website.
I'm sorry, what's the question? Whether you can...
You can buy and you can sell our product only via website, and use only website without software.
Okay, or you mean versus downloadable software?
don't
Yeah.
look software. It's real.
Yeah, I think we're definitely moving more towards where we can do more things on websites and less downloadable. Especially, I do have some downloadable software that I sell, and every year there's more and more problems with getting blocked by Windows. So I think the cloud is definitely the future. Yeah, you're welcome. Okay. Yes, Shino?
Do you have any advice about security? I'm not talking about exposure but security. If you want to use the internet, maybe somebody wants to hack and steal everything.
Yeah.
Of course, if you can use a test center like Pearson, it's okay, but it goes out. Without trying to test center, what do you like?
Well, there's levels of security you can put in place at the student level, like having virtual proctoring, lockdown browsers, all that sort of thing. That helps and is not too expensive. In terms of preventing hack, that's where you need the IT experts working with AWS and doing security stuff that I don't understand. But I've heard it's actually comparable security to using test centers like Pearson. Sorry, Kathy. I say that also because I have downloadable software too. And if you're going to deliver tests like that, the entire item bank has to be packaged with it. And you're giving that package to test centers, some of which are not trustworthy. And I know that because that's what I do in my software too. You got to put the whole item bank in the package. So if that's decoded, they see the entire item bank. Cloud-based, in some cases, you've only got any terminal node is only going to see the small portion of items. They don't have access to the entire bank. The entire bank only resides on an Amazon server behind whatever firewalls you have and other security aspects. Welcome. Okay. I'll turn it over to my colleagues here then. Thank you.